Okay, so we'll get started talking about this warm-up. So, looking at this problem, what do you notice first? What do you see first? So we have those parentheses. The parentheses automatically tell us we need to distribute in the problem. I'm not plugged in. And so we distribute. What are we distributing? The 6. So that 6 is being distributed to each value inside the parentheses. So what's 6 times 2y? Y. And then 6 times -7? -42. And then that's still equal to what we had on the right side. Okay. So now that we got that, what else do you notice? We have 2 y's. We have 1 y on the left and 1 y on the right. So we need to combine those together. We need to combine like terms. How can we do that? What was that, Destiny? Subtract 4 from both sides. Okay. And once again, this might be different from what you did. And that's okay. So you can choose to put them all on one side. You can choose to put them all on the other. It'll still get you the same answer. So we'll subtract 4. Subtract 4y. Good. 8y minus 42 equals -18. What would you like to do next? Add 42. So we will add 42 to both sides. Inverse that constant, as we call it. Okay. Okay. So we'll add 42. What's -18 plus 42? 24. So we have 8y equals 24. Last step. We need to inverse the coefficient. So we need to get rid of that 8 in front, so we'll divide by it because it's being multiplied. And then we get 3. Awesome. How can we check this if we wanted to? So if you ever need to check, just take that 3, plug it back into both of those y's. As long as they equal each other, you're good. Any questions about solving equations from what we did yesterday? Or any of the steps we did? Okay. So today, we're going to talk about order of operations. So once again, this is probably something you've learned before in your previous math classes that we want to bring back to the forefront of our minds. Practice those algebraic skills just a little bit more before we jump into the meat of algebra. But when I say the word order of operations, what does that mean to you? What comes to your mind?
Operation.
PEMDAS. What does the word PEMDAS mean?
Parentheses, exponents, multiplication, division, addition, subtraction.
Exponents, multiplication, division, addition, subtraction. And how is that supposed to help me? What does that involve with order of operations? What does that mean?
It's the order in which you do
The order in which we do it. So whenever I'm solving or whenever I'm evaluating an expression, I need to start with my parentheses, get rid of those first. I need to then go on to my exponents, my multiplication, division, addition, subtraction. Do I always do a multiplication before division? So we do them at the same time or as the order they appear in the problem. So if division appears before multiplication in the problem, do division first. If subtraction appears before addition in the problem, do subtraction first. That's just the order in which we say it, the order in which we have it memorized. But really, multiplication and division are happening at the same time. Addition and subtraction are happening at the same time. It really depends on the order or the time they appear in the problem. So we okay with PEMDAS? Okay. So I really like PEMDAS. It's good. But I'm going to change it just a little bit. So rather than saying the word PEMDAS, we're going to use something now called GREMDAS. So rather than having parentheses as the first word, we're going to change those first two words, or we're going to change that word into we're going to split up. So that first word of GREMDAS is now, instead of being parentheses, it's going to be grouping. So sometimes, not all mathematicians are the same. Not all mathematicians use parentheses. Some of them use brackets. Sometimes you have these funky squiggly curly brackets. Not really, but typically it will either be parentheses or brackets. But these are grouping symbols. So they function all the same. They're all just like parentheses. they group those things together. And they group those operations together. So rather than looking just for parentheses first, we're going to look for those grouping symbols. So you might see a bracket, you might see a curly bracket. But it's all the same. It all means the same thing. So even though it might look a little different, it still means the same thing. So that's the first thing we're going to always look for. Next thing we're always going to look for is going to be radicals. I don't know what radicals are. Not a circle radical, but so radicals are like square roots, cubed roots, on and on. So whenever you took a square root in the past, so what's the square root of 4? 2. So what two numbers multiply together to equal that number? And so radicals is another name for the square root symbol. So rather than starting first with exponents being the next thing, if you see these radicals, if those ever show up in your expression, those are going to actually be the next thing you're going to look for. And so if you saw, you had your parentheses of 7 plus 2, you do that first, and then you would do the radical. So 7 plus 2 is 9, and then you would take, what's the square root of 9? That's your next step. And so on and so forth. So that's the only thing we're going to change about our order of operations from before. Rather than just having parentheses, that PEMDAS, we're going to change it to GREMDAS, and we're going to add in grouping and radicals. The rest will still be exponents, multiplication, division, addition, subtraction. And that will be the same as well. Do we have questions about the grouping or radicals? So, funny story really quick. I have this math t-shirt that says math is radical, and it has like math, but it's under the radical, so it's radical. It's pretty great. I'm a nerd. Okay, let's keep going. Pretend I didn't say that. So let's practice a little bit. So we're going to practice this GREMDAS now. Just practice this order of operations to make sure we can remember how to do it. We'll do the first one together, and then I'll see if you can try the second one on your own. So looking first, what do you notice about this problem? Parentheses. We have some parentheses in this problem. So what would you do first then? So parentheses comes first, so we have 5 plus 7. So we want to do what's inside the parentheses first. So 5 plus 7 will give us 12. Now that we've done the parentheses, what would you like to do next? Radicals. Unfortunately, we don't have any radicals in this one, so we can move on to our exponents. What exponent do we have? 2. So what is that going to do? So with exponents,
It's 144.
so when I have an exponent, 12 to the second, this doesn't mean 12 times 2. What it's saying is it's 12 times itself, and then the number of times you multiply by itself is that number. So 12 times itself twice. So 12 times 12 will give me 144. So I'll actually have 144. So what should we do next? 20 minus 144? 144 divided by 9. 144 divided by 9. What would that give us? 16. Awesome. Finish it off.
4.
This equals 4. Are we okay with this?
Sure.
I'll erase. Do you want to try this one on your own, or do you want to do this one together?
No, we can do this one on our own. We're going to try it on our own because we're...
Try it on your own? Okay. Take a moment, see if you can do this one on your own, and we'll be right back. So let's bring it back and talk about what we did. So what do you notice first about this problem? What stands out? The radical. So we need to take... So we need to take the square root of 64 first. Right? So the square root of 64 is 8. Once again, the word radical and square root, they are the same thing. So if I ever say the word radical and you're confused, it's the exact same thing as the square root. So the square root or the radical of 64 is 8. And once again, this is a multiplication symbol. I'm sorry for that you got confused. So what do we do next? Bradley?
Question.
Yes. Are you allowed to use your notes on the test?
It's not no, we don't know what about that.
No, we don't worry about it.
No, I've never been able to use notes on the test.
Yes.
Not in my class, I'm sorry.
Okay, now we
Ours
can
was a
do
Alright, so now we would jump to multiplication.
Yes.
So 19 times 8, which is 152.
plus 5.
And then plus 5, which gives us 157. Are we okay with this? On the order we chose to do those? Okay. So. Okay, so looking at this first one, what do you notice is different about it? It's a fraction. So division sign or fraction, they mean the same thing. So based off of this information, what are your thoughts? How would you go about solving this? Or simplifying this? Ashton?
I do the addition first and then divide it.
So we can start with the addition first. Even though we're starting with addition first, that seems backwards from what we should do. Because typically you think addition's at the very end. But because this is a fraction, even though it's not written up there, there's these hidden little parentheses that's keeping these up in the
Dollar General?
put them out of my pocket. So there's these parentheses that are hidden in that numerator of that fraction, holding all that together. Same thing in the denominator. There's really parentheses around this 13, but because it's a number by itself, it doesn't matter. So we can do the numerator first. So what's 4 plus 9? 13. So we have 13 over 13. So if we were to stick to our order of operations, we would do the 7 squared first, which will give us 49. What will come next?
Divide 13 by
13 over 13, which is
1. Minus 49.
48.
How do you think it?
Yes.
Oh, I was right. I get a 48.
Are we okay with this?
Yes.
So something you also want to pay attention when doing order of operations is if you have a thing like this where it's a fraction, if you have something where it's under the radical, those are all grouped together. So that's another way of where it sort of jumps order and it jumps back into that grouping, is if it's on the numerator and the denominator, if it's grouped together. Are we okay with that? Do you want to try the second one?
Yeah.
Yes, sir.
Is it 125?
You do the radical. You do what's in the radical.
So
We do like
we would focus on this first, but then we use order of operations once again. Now just focusing on this first. So before that, we do. So see if you can finish this second one. So what do we end up doing? What did you look at first? So we look at what's under the radical. So this radical extends all the way across, covering up everything. So everything under that radical we need to get rid of, or we need to finish first, or simplify first. So under that radical, what do you notice? What should we start with? The exponent. So we have 3 squared, or 3 raised to the second power. So that becomes 9. So we have 5 radical 16 plus 9.
Oh.
So what do we need to simplify next?
16 plus
16 plus 9 gives us 25. So we now have 25 under the radical. Now that we have a single number under the radical, we can take the square root. What's the square root of 25? 5. So we have 5 times 5, which gives us 25. Solid.
I forgot the radical.
All right, we're gonna have one final order of operations problem. So looking at this one, what do you notice about it first, though?
Brackets and brackets.
So what do you notice about this one?
There's everything.
So we have brackets. What else do we have? A radical. What else?
And parentheses.
Parentheses. We have brackets and parentheses, though.
Parentheses first.
So why should you do the parentheses first? Because they're inside the brackets. So because the parentheses are inside your other grouping symbols, this one will take higher priority. We always want to work from the inside sort of out. In a sense. Yes, Ashton?
So if you have to put parentheses, you want to use brackets instead of parentheses.
If you have to do multiple sets of parentheses, I would recommend using a different set like brackets. That way you can specify. So I know these brackets go together, and I know these parentheses go together without confusing this parentheses and that.
Do it again, you use it for things.
You can, yeah. Or you can switch back to parentheses. It's really up to the mathematician's opinion. So what would you do first on this problem? 7 minus 4. What is 7 minus 4? 3. What would you like to do next?
Divide 9 by 3.
9 divided by 3. So if I have a single number in here, do I have to have those brackets anymore? No, I can rewrite that.
You could.
I could, but I don't need it. What would you do next? 20 times 5. You want to look what's under that radical. What's under that radical? Which is 100. Square root of 100? Good job. Do we feel okay with order of operations at the moment? Bring it up. So Grundos isn't too intimidating. Changing that up.
It kind of sounds like Grundos.
Kind of sounds like Grundos. Yeah. All right. We're going to do one final thing. That was our final problem. This is more of a fun. No, I don't know. It's a thinking activity. All right. So I have these boxes up here.
5, 2, 4, 6, 9, 7, 21.
Right, without numbers. So we have these boxes up here. Your task, you have the numbers 0 through 9. So you have those 10 digits. You need to put those numbers, you can only use them once, in these boxes. So you can only use each digit once. So I can only use a 9 once. I can only use a 3 once.
7 boxes.
Your goal is to try to get the largest number. So you can choose where you want to put those numbers. You want to try to make the largest possible number. If you need a calculator, I would recommend it. That way you can check your answer. But start putting some numbers and see who can end up with the largest number.
No.
So I recommend using these bigger operations.